right, ladies and gentlemen, so let's go through this, and it goes pretty much in order to our note packet. And again, this is what the test is going to look like. So first 3 questions are just rewriting these using our exponential notation. So if I have 5 to the 8th 10 times, and I'm going to put it over here on the test, you of course should put it on the answer line. But that means 5 to the 8th, or 5/8, sorry, with an exponent of 10. Making sure that you put your fraction into parentheses. Here we have the 12 tells us that I'm doing this 12 times, 2.5 times 12. Now we're using some variables, so my base is y, and they're telling me that I'm doing it z times, so y to the z power. For number 4, so now we're going through using our rules. So you have to first look to see what type of problem is it. Adding, subtracting, multiplying, dividing, or a power to a power. And the first 3 are our multiplying, which means we're going to add the exponents. So this is going to be m to the 13th. Here my base is 8. Remembering if you don't see an exponent, it's a 1. So 2 plus 1 plus 30 is 33. And for here, we're going to multiply the numbers out front, which is negative 40. Then we're going to add our exponents, x to the 19th. Next 2 problems are our dividing, which means we're going to subtract the exponents. So we're going to keep the base, 2.2. 6 minus 5 is 1, or you could just write that as 2.2. Here I have some coefficients out front, so I'm going to do 18 divided by 6 is negative 3. 30 minus 15 is going to give me w to the 15th. Next set, here I have, these are my powers to a power, so we're going to multiply the exponents. So keep your base of 6. 7 times 9 is 63. Keep your base of x. 3 times 14, I hope is 42. I hope I did that right. When I have more than one thing inside the parentheses, we're sharing our exponent with all of them. So this should be 4 to the 5th, x to the 5th, and for y, I have to do 3 times 5, so y to the 15th. For number 12, here I have 3 exponents that I'm multiplying. So I'm going to keep the 2, and I'm going to multiply all 3 of those things together, which again I hope is 36. Next, we have our fun and fabulous exponent of 0. So anytime we have an exponent of 0, we're going to get an answer of 1. Here, 10 minus 10, this would become 7 to the 0 times 2 to the 0, which is 1. Anything divided by itself is 1. For number 12, so remembering that when we did a very little bit of this, so as long as you can maybe write this down on your index card here. So 10 to the negative 6, so this means 10 times 1 over 10 to the 6th, which is 7 over, right? Put that over 1. 10 to the 6th is 1, 2, 3, 4, 5, 6 zeros. So you could leave it like that, or you could turn it into a decimal. 1, 2, 3, 4, 5, 6 decimal place. So either way that you could do that. Over here, simplify z to the negative 5th using positive exponents. So this is where we're going to be dealing with putting them into fractions. So z to the negative 5th tells me I have to turn it into a fraction, and that makes the exponent positive. For number 18, I'm going to subtract my exponents first because it's a division. 18 to the 4 minus 12 is negative 8, which means then, I'm actually going to put this one over here, would be 1 over 18 to the 8th, right? Because we want it as a positive exponent. Here, right, I'm going to, again, distribute this first. So this is going to be 6 to the negative 3rd and m to the negative 18th. These are both negative, which means they're both going to end up in the denominator. 6 to the 3rd, m to the 18th. If you wanted to go through and simplify 6 to the 3rd, you could do that, but you don't need to for this one. And simplify 3 to the negative 5th using positive exponents, so that's our basic 1 over 3 to the 5th. Steve answered a test question by writing the following. Did Steve answer it correctly? No. Because -8 needs to be in parentheses. I'm being lazy. You are not allowed to be lazy. Only me. Haha. Number 22. Jenna wrote -1, Will the product be positive or negative? How do you know? We're looking at our exponents. Odd exponents will give me a negative answer. Right, because that means we're multiplying an odd number of negatives together. Can the following expression be simplified? If yes, write an equivalent expression. So I can do these because I have these bases go together and then these bases go together. So it's a division problem, which means I subtract my exponents. So that's going to give me 4 to the 30th and 8 to the 7th. Now, for those of you that want a challenge, I could rewrite each of these with a base of 2. Right, so this is a challenge part. This would be 2 squared to the 30th and 2 to the 3rd to the 7th. This one's sufficient for the test. Now I'm trying to get you to go a little further. But anyway, so this is going to be 2 to the 60th, 2 times 30. This is going to give me 2 to the 21st. Which means now, if I add those, it's actually the same as 2 to the 81st. Again, if you can do this part, I'm good for the test. So write the expanded form. So this is where we're counting decimal places. So this is 3 times 10 to the 5th place, plus 2 times 10 to the 4th, because it's 4 places over, 7 times 10 to the 3rd, 8 times 10 to the 2nd, 6, I screwed that up. Sorry, I'm off by 1. Let's do, sorry about that. 10 to the 4th, 10 to the 3rd, 10 to the 2nd, 10 to the 1st, 10 to the 0, and then 1 times 10 to the -1st. So again, if this is going to be on the test, then I would absolutely make sure you put that on your index card. Show the fractionally equivalent to, so fractionally equivalent means they want you to actually multiply it out. So this is going to be 7 over 2 to the 5th, and then 2 to the 5th means 2 times 2 times 2 times 2, and so on, but that gives you 32. All right, hopefully you're finding this pretty easy, but this is what your test is going to be like. Can you believe it? A 1-page test. Any questions, as always, bring them to class. Have a good night, guys.